Machines understanding human language is a fascinating journey into the realm of natural language processing, or NLP. At its core, NLP is about bridging the gap between human communication and machine comprehension. Let's dive into some key principles that make this possible. First up is tokenization. Imagine breaking down a sentence into its individual components, words or phrases. This is the first step in helping machines make sense of language. By segmenting text, we allow algorithms to analyze each piece, paving the way for deeper understanding. Next, we have syntax analysis. This is where the structure of sentences comes into play. Machines need to grasp grammar rules to understand how words relate to one another. Think of it as teaching a child the basics of sentence construction. By analyzing syntax, machines can determine the relationships between words, which is crucial for accurate interpretation. Then we move on to semantics, the study of meaning. Here, machines learn to associate words with their meanings, context, and nuances. This is where things get interesting. Words can have multiple meanings depending on their context. For example, bank can refer to a financial institution or the side of a river. Understanding these subtleties is vital for machines to respond appropriately. Sentiment analysis is another exciting aspect of NLP. This is where machines evaluate the emotional tone behind words. Are we expressing joy, anger, or sadness? By analyzing the sentiment, machines can gauge human emotions, which is particularly useful in customer service or social media monitoring. Named entity recognition takes this a step further. It involves identifying and classifying key elements in text, such as names of people, organizations, or locations. This helps machines extract relevant information quickly, making it easier to process and respond to inquiries. Now, let's talk about context and pragmatics. Language is not just about words. It's also about the context in which they are used. Pragmatics deals with how context influences meaning. For instance, the phrase, "Can you pass the salt?" is not just a question. It's a polite request. Machines need to understand these nuances to interact effectively with humans. Shifting gears, let's explore rule-based systems. These systems operate on a set of predefined rules and logic. Their architecture typically includes a knowledge base, which stores information, an inference engine that applies logical rules to the knowledge base, working memory for temporary data storage, and an input-output interface for communication. This structured approach allows for clear reasoning and decision-making. However, rule-based systems have their limitations. They can be rigid and may struggle with ambiguity or unexpected inputs. This is where modern NLP approaches like machine learning and deep learning come into play. These methods offer greater flexibility and adaptability, allowing machines to learn from vast amounts of data and improve over time. When comparing rule-based systems to modern approaches, we see differences in logic and interpretability. Rule-based systems are transparent. You can trace how a decision was made. In contrast, modern NLP models often operate as black boxes, making it harder to understand their reasoning. Data requirements also vary. Rule-based systems rely heavily on expert knowledge to define rules, while modern approaches thrive on large datasets, learning patterns and relationships from the data itself. This leads to a broader range of use cases, from chatbots to advanced language translation systems. In summary, the evolution of machines understanding human language is a complex interplay of principles and technologies. From the foundational aspects of NLP to the structured logic of rule-based systems, each component plays a vital role in enhancing communication between humans and machines. The future of language processing is bright, with endless possibilities for innovation and improvement.